scientific notation is used by scientists, engineers, anyone dealing with large numbers. So if we've got a large number, we're just going to use 1,000,000, and sometimes it can go on for many, many, many zeros after that. Scientific notation is changing that 1,000,000 to this format here. Now, if you notice, or if you remember from our exponents, 10 to the 6th power equals 10 times itself 6 times, right? And if you notice this, 10 to the 2nd power is 10 times 10 is 100. So 10 to the 3rd power is 10 times 10 is 100 times 10 is 1,000. Do you see where I'm going with this? Whatever number is there is how many zeros you have after the 1. So 10 to the 6th is 1 with 6 zeros. And we like to put commas in to make it clear. So 1,000,000 is 10 to the 6th. And again, the point here is the exponent on 10 is the number of zeros after the 1. So if we have 2 times 10 to the 6th, that's the same as saying 2 with this many zeros. 1, 2, 3, 4, 5, 6, and putting in the commas. And also many times we will see something like this. All that's saying is you have 2 and then you have 1/6, because that's where this comes from, right? The original decimals here, that's the original decimal location, but we're going to move it over to the right 6 places. So we're going to go 1, 2, 3, 4, 5, 6. And if we fill in the commas, we see we have so another easy way to think about scientific notation is just this number here tells you when it's positive how many places to move the decimal that way. So what if we have a negative number there? Well, instead of counting the decimal places that way, we are going to go this way with negative. So we write our 216. The original decimal location was right there. But we know that we have to go to the left, because it's negative, 3 places with the decimal. So we're going to go 1, 2, 3, put the decimal there, and fill in these little ovals with a 0. So this expression is equivalent to 0.00216 with a decimal there, 0.00216. And it's very important to realize, use our same example, just because this is a negative exponent does not mean the number has to be negative. The final result has to be negative. Remember, this is an implied positive sign if it's not included. So this will be a positive number. If instead we had a negative 2.16 times 10 to the negative 3, then yes, that will be a negative number, not by virtue of this negative exponent, but instead by virtue of this negative sign. Okay, now let's go the opposite way and say we are given a large number, and I'm looking at example 9 on page 28. Let's say we're given this number. That's a large number. How large is it? Well, let's take a look. let's see, that's hundreds, that's thousands, that's millions, that's billions, so that's trillion. So this is saying 34,970 billion. We don't know what the units are. We don't know if it's dollars or atoms or whatever, but that's what that's saying. Okay, so now we want to convert this into scientific notation, true scientific notation. So what that's saying is we want the decimal to go right there. So, and not engineering notation, and there's some others as well, but we're just going to stick with scientific. So we know that we're going to have 3.497, and I could stop there because the rest are going to be zeros. We're going to have to count over how many decimal places we have to go to put this into scientific notation. And we stop there because that's where we're bringing down the decimal. So we counted 13. So we're going to have that times 10 to the 13th power. Oh, and I just noticed on closing on this section, that should not say billions. That should just say billion. Okay, now we will do multiplication of scientific notation. And I'm looking at example 11 in the text on page 29. Okay, now with multiplication, unlike addition and subtraction, with multiplication, it's actually easier because we can regroup by like terms. Like terms are these two and these two. So we can rewrite this whole expression. And remember, when we have the same base number as we do here, what we can do, what the law is with exponents. These are added. 4 is, if you punch that into your calculator, 24.4 times 10 to the 5th power minus the 9th power. And again, we got that from here. To the negative 4th power.